Good morning, everybody, and welcome to this morning's webinar on questioning machinery safety integrity. We're going to talk this morning about the safety life cycle on a machine. Let's call it an entry-level overview. I promise that I won't bore you with lots of information on standards. What I intend to do is try and give you an insight into all of the activities you need to make a machine safe. And then this is the beginning of a series of webinars that will help you build the whole picture on machinery safety. So let's start by introducing the speaker today. That was myself. I'm the product manager for IDEC safety products in EMEA. And I have a background in machinery safety going back over a period of 24 years. Had a responsibility for design and development of safety products and sales as well. Risk assessment and design, allocation of safety functions on machinery, and practical engineering design experience, and a lot of working with remediation machines and working with customers who have got projects to remediate their machines. Probably most importantly, I'm part of an IDEC team of safety and automation specialists who understand about building machinery. We understand the problems of CE marking and getting the whole production line going once those machines have been received at the end user's factory. So making the machines safe in the production line. So this presentation will address the process for making machinery safe. As I said before, we won't go into all of the detail. This is an overview, but I want you to come out of this understanding the competencies are needed to make equipment safe. And we'll talk about the steps that anybody has to follow in order to make a machine safe for use and, of course, safe to be put onto the market. So we have to start with competency. We need to ensure that we are aware of the directives and the laws that are necessary in order to make the equipment work in a safe environment. Starting within the European Union, we have directives. Many people have heard about CE marking. And of course, if you want to place a machine on sale or into service in the European Union, then you have to apply a CE mark to it. But what about once your equipment is already installed? May have been in there 5 or 10 years. There are also directives that ensure that you have a process to protect and make sure that your work equipment is safe. And when you buy multiple machines and join them together, you have to understand that there may already be a CE mark on machine number 1, but not on number 2 because it's very old. So you have to understand about the integration of machinery. And in order to do that and enhance that understanding for both the users of equipment and the users of equipment and the people who are producing it to join it together in a line, there are standards. And those standards are there to meet the minimum requirements of the machinery directive. So I promised you that I wouldn't talk much about standards, but there are in excess of 3,000 standards, and we will cover those in another seminar, not all of them. But the idea is that if you follow the standards that are in place, then you will be able to presume conformity to the machinery directive. They provide the minimum requirements, and you can, of course, do more than that. If you don't follow the standards, then you are in danger of introducing errors into the system. Not understanding and not being competent to use them and the correct application of them will lead to systemic errors and faults in the safety solution and the design of your machine. So it's absolutely essential throughout the life of the machine, throughout the development life of the machine, that people who work on safety on equipment are competent to do so. Now, we've all been there in a factory, or we all know people who have been there, where the machine breaks down, it's midnight, there's a product falling all over the floor, and there's a need to replace a device. Now, clearly, if it's an exact swap, that's no problem. But what if we were to change a device that creates the same functionality, so the device actually does the same thing, but do we know whether or not it's actually delivering the same level of integrity? We probably don't. So for that reason, later in the presentation, I'll talk to you about the effects of making changes that do change and literally make the safety function different, though the machine function remains the same. So there's no safety in part numbers. The thought about the method of buying a part, fitting it and forgetting it is no longer appropriate. And a sobering thought is that 20% of control-related system failures happen as a result of changes that were made after commissioning. So the line was up and running, it's all been set up, looking good, but then somebody comes along and makes an alteration that affects the integrity of that machine control system. Maybe it's just its performance. But changes made after the system was commissioned result in 20% of accidents if it's control-related. So there's a process that you have to go through, and you go through all the stages, the life stages of the machine in order to make it safe. And for the end users to keep it that way, that's a whole life cycle, right the way from when they accept it into the building all the way through to when it's decommissioned. And you might say, well, surely if I'm decommissioning a machine, I don't have to worry about that. It's gone, it's scrap. Well, I'll take a simple example. A hydraulic press with a reservoir. It's switched off the last time it's used and decommissioned within an hour. The hydraulic fluid may still be under pressure. Loads may still be elevated. The temperature of the fluid will undoubtedly be 65 degrees centigrade, which is the human threshold temperature. All of those things need to be taken into account before you can safely decommission. So let's now build that process. The life cycle takes you through 6 steps, and it determines the skills needed to do that. Each step ensures that you address all the requirements of the machine. And probably most importantly, it starts with assessing those that are using the machine, those that are interacting with the machine. And then we develop the project, and then we have to look at the life of the machine in its application, how we maintain it, and then how we look after the safety functions that are installed on the equipment. It's a common myth that safety devices fail safe. Well, that's actually not true. Safety devices do fail safe, but they are not indestructible. And if you hit them hard enough and long enough, they may fail in an unpredictable manner. So you have to maintain safety functions and check that they are performing their function properly and that they will continue to do so. So we start the process with risk assessment. Why assess the risk on a machine? Well, by doing a risk assessment, we can determine all of the hazards that exist on the machine. And then we associate those hazards with the people who are working with it. We look at all of the tasks that the people are doing on the machine, and then we associate their interactions with those hazards and come up with a plan and define how we're going to reduce those hazards to an acceptable level. And that becomes a cyclical process. So risk assessment is the first step, and it is an essential step in order to make sure that you have identified everything you need to do at the beginning of this cycle. And once you've got that list of things that you need to attend to, you need to create a specification. A safety requirement specification defines the actions and the reactions of what we require from the safety system. But what could a safety system be? Well, clearly we want to separate the person from the hazard. So perhaps there is a guard. It might specify the height or the size of the guard or the distance from the operator. It might specify the time that it takes for the separation of opening the door guard to when the hazard goes down. But most importantly, it defines what happens as a result of opening that guard. The worrying thing is that errors at specification stage account for about 44% of control-related accidents. So if we are aware that 44% of accidents occur as a result of changes that of design errors that were there, surely that means also that there may be latent errors in machines that we haven't yet discovered. Again, I mention the word cyclical because all the time, if we keep doing risk assessment on a regular basis, we may have the potential to detect those errors and faults at an earlier stage, and ideally before an accident occurs. The safety requirement specification lays down the foundation for the design to be installed. And it creates a checklist of every action and reaction of the safety system. It becomes an instruction to all of the members of the design team. And if you have studied functional safety at all, you will see that there is a requirement for review, check, and review all the way through the life cycle of a piece of equipment. And with that, the instruction goes to the members who build the machine up, and they then identify whether or not their design is going to meet the requirements of the risk assessment. And probably the single most important thing, it creates a baseline for validation. At the very end of this presentation, we will talk about the validation of the installed equipment. There is no point in creating a safety requirement specification if you do not validate that what you intended to do has been achieved. So we have our engineering, design, and verification process. The risk assessment designed the protective measures to reduce the risk of exposure to hazards. And with the correct design, and then with verification, we should check the solution against the design requirements. It is an absolutely critical time in the process that we evaluate what we are going to do, and then we confirm the integrity of what we are going to do against the requirements of the risk assessment. And there are risk assessments against the functionality, the people putting their hands into a machine, their time of exposure. We talk about the performance level of the safety control system that's going to protect the people. So as we go through and we design our safety requirement function and we design our safety function equipment, we also have to identify whether or not it will perform according to the expectations of the assessment. That then gets set out as the performance level required of the safety functions. And later on in another webinar, we'll talk about the performance level required and the minefield that does actually become. And most importantly, the verification process checks that the safety functionality can be performed in such a way to prevent dangerous failures. Nobody wants to open a door and find the machine still running. And of course, if we can't actually protect against those dangerous failures for any reason, then we may have to ensure that the person isn't exposed to hazard as a result of that. Nothing is fail-safe, but we can do a great deal through this cyclical process to ensure that we have identified everything that can go wrong and how we can protect against it. So verification of the installation. There's a lot more to safety on a machine than gates, guards, and interlocks. I say that because quite often when you visit factories and you look at a safety application, they have a checklist on the machine and it says, does the guard work? Is it broken? Does the machine switch off? And it's true, the machine does switch off. But was it the PLC that switched off the machine? Or was it in fact the safety function that you've just employed to stop the machine? So by using verification of the installation, we go through a series of checks and we ensure that the installation actually does what the original specification required it to do. So if in the safety requirement specification it said 2 channels shall shut off the safety function, we make sure that both channels shut it off and that solution is fit for the purpose for which it was intended. And as we apply our theory into the machine, we start to take it into the field, We stand in front of a machine. For all the best intentions, when we started, we expected, for example, that the machine was specified to do 4,000 revolutions a minute and an anticipated stop time of 200 milliseconds. But actually, when we stand in front of the machine, the reality is that it's running at 8,000 revs and the stop time is 400 milliseconds. Suddenly, that guard is too close. And it doesn't matter how reliable your safety function is, the hard installed truth of this application is it's not fit for purpose. So machine stopping time and verification of that is something that we will cover in another webinar in the near future. Validation of the safety functions. This is probably the most critical part and involves the highest level of competency. We have to check the function of the devices, the hardware, the guarding, the control, and also the software, often neglected. The breadth of competency to check this is really quite significant. And normally you would use an independent team of people to validate the machine. If you allow the originators, the people who did the actual design, to validate their own work, it's inevitable that they will be blind to their own errors. So by bringing in people who are independent, who have a separate role or task for that particular project, they can then ask questions and challenge the integrity. Typically, you would want at this stage to have somebody from the safety department and an engineering design department, hardware guys, software guys, and possibly also the opportunity to bring in production people who may recognize a reality. And when I say a reality is you've designed the machine to work in this way or the application to work in this way, but actually our operators unload to the left and not to the right. So production people have a very valid part in the task of validation and the whole cyclical process. And when the tests and validations are going on, there's quite complicated work that takes place. We create faults, we inject faults, we put errors in. It's a little bit like, probably a little bit severe, but when you're driving along the road and you put your foot on the brake, it works every time. That's because both brake circuits are working. Fault injection would be to cut one of the brake circuits and see whether or not you still stop. Possibly not something I would recommend whilst you're driving, but certainly the type of work we would do on safety and we would look at with customers to make sure they're doing it properly. So fault injection ensures that the machine safety functions are working properly and are resistant to the hazards and resistant to errors that might make them go wrong. And the utilization and maintenance phase, well, 15% of control-related accidents that are linked to the maintenance phase and changes that are made during the operation phase. So, for example, an operator winds the speed up, like I mentioned before. The stop time now becomes too long, and the safety control system can't react in sufficient time because the machine is running so fast. But changes made after commissioning, modifications and upgrades, the addition of another machine downstream. This is where we see 20% safety-related accidents on the control system. That is really, really a concern. And it is for that reason that competency, following the standards, making sure that you are actually doing it compliant is really important. And hence we go back to the risk assessment, because if you're making a change to a machine, it's quite likely that the change you have made was not in the scope or vision of the person who originally designed that machine or designed that line. So every time you make a change to a machine, you should review the risk assessment and see whether or not the safety function is in fact going to be an issue or whether or not it will go wrong. Competency really matters. So let's just retrack. Risk assessment, I did promise I wouldn't mention standards, EN ISO 12100. Safety requirement specification. Ensure that you have got all the requirements and behaviors of how you want the machine to work aligned with the functional requirements of the operators who have to work that machine. That you understand what the control devices are going to go off and how they are going to stop and how they are intended to behave in the event of a dangerous situation. Engineering and design and verification. Once you have got your specification and you start to create that design, you have to ensure that its integrity will be sufficient for the lifespan and the functionality of the dedicated requirements of that machine. And verification of the installation. Does it still do what it was supposed to do? That can be when it's new or at any point during the operation of the machine. It's always worth going back to check, is it still fit for purpose? And validation. If you make a change, if you make a modification, go in, validate that everything works as is required by the safety requirement specification and the risk assessment, and is in line with the standards associated with that particular type of machine. Maintenance. I can't stress enough how important it is to maintain the machine and check the integrity of the safety function, not just the fact that the machine stops. Make a regular review, take a look at the safety control system, see whether or not it's still fit for purpose, identify whether or not that safety function can be improved in any way. It's a cyclical process and one which you have to address in a reasonable period of time. Typically, people would do a risk assessment every 2 years on a piece of installed equipment. And of course, a machine builder does a risk assessment every time he designs a new piece of equipment or he makes a change to his design. So do you have what it takes? Well, at IDEC, we can help contribute towards that and assist you with your competency by addressing your needs. Products and application assistance we provide from automation right the way through to the safety equipment. We have integration partners and assessment partners who can take on the larger, more extracted process. And our safety partners and our automation partners and our supply chain are here to ensure that everybody gets the products they need on time. In particular with safety, when if it's broken, it needs to be up and running immediately. So IDEC intends to provide automation and beyond. So we have some up and coming webinars. We'll be looking at PLCs and help in the selection. We'll be talking about safety distancing of devices, safety controls, as I mentioned, the performance level minefield, and also we'll be touching on the correct application of safety devices coming up over the next 3 or 4 months. But that's just my vision. Perhaps you might want to email me or text me with any additional topics that you may wish to cover. So thank you very much for your time. And I could hear some questions coming in while I was presenting. I've not been looking at the questions. So if you just bear with me for a second while I switch the screen, and I should be able to see everything that you've asked. Gosh, you've asked a lot of questions. Right. Okay. Many questions. Okay, got one question. A couple came in advance as well. One question about the difference between directives and standards. In simple terms, a standard is a guidebook. It is the best way of identifying the requirements to make a piece of equipment safe. The directive is put in place by the European Union, and it instructs each member state to have a law that makes that directive applicable in that country. So forgive me if I talk about the machinery directive, and for example, in the United Kingdom, the machinery directive is held in British law by the supply of machinery regulations. And the same occurs with a particular decree in France, and the same occurs in Germany for the machinery directive. But if you're using equipment, then you've got the work equipment directive, and that applies to people who run factories. And that's quite simple, really. It just means that you are told how to place work equipment into the factory safely, and how to ensure that you do a regular assessment and checks and all the behavioral side of having the equipment installed. It does expect you to look at the standards. So you take the standards as a guidance note on how to do it. And that's particularly important when you have modifications to machines. So let's have a look at some other questions going down here. Andrew's been a bit prevalent on questions. Right, okay. If you've got a risk assessment in place, some people say, well, surely that's a bit subjective. That's my opinion or your opinion. No one person should do a risk assessment on a piece of equipment. It should be a team effort. If I was standing in front of a machine, let's say, for example, the one I've already done, a tire making machine, I would expect to have the operator present. I'd expect to have the production manager present, and engineering, and probably somebody from within the safety department. Why do I have that group of people? Well, first one is operators. They know how the machine's really used. If you have a night shift, I'd get a night shift guy in as well, because then you'll find out how the machine is really used at night shift. It is quite important because it does differ. If you take a risk assessment task and you go through, each of the people write down and identify what they see as a hazard, and then they evaluate that level of risk. They need to be competent to do it. They need to have had training to do it. And then together as a team, they bring that together and they identify their findings. Their findings are also embedded together in a file, but ultimately a senior manager or a senior safety engineer or consultant has to make the decision on what the risk level is and set the measure against that. But it's so useful to have the right people interrogated. So hopefully that answered that question. What else have we got here? Lots of questions. Thank you, Andrew. Okay, so you've got a customer who makes his own machines in his own factory. That is really common. So I've got my own factory. I have my own manufacturing department. In fact, we also have the same here at the APEM factories. And we produce our own equipment. Does that mean that we have to have a CE mark? Yes, you do. The Machinery Directive has instructions which say that if you provide equipment and place it into service, it shall conform to the Machinery Directive. Emphasis on service and not sale. If it is in service, it's deemed to be in the marketplace. And the reason that's a concern is because next year we could sell that machine. And if that machine goes into the open market, it has to have a CE mark on it. So you have to go through the CE marking process, do the risk assessment, look at your safety requirement specification, do your design verifications, and follow the cycle. What other ones we got here? If we've got one other one, then what was it? How are we doing for time? Don't know. Yeah, okay. Customer builds machine. Okay. If you are working as a machinery builder and an OEM, it's absolutely mandatory for you to put a CE mark on your machine. We will do another webinar on CE marking and the requirements. Yes, I'm in the United Kingdom. Yes, in a couple of months, I won't be part of the European Union, well, unless something changes drastically. But the rules, methodologies, and applications all require the same. I've got a question here on HMIs. We often get requests for CE mark components. Is it mandatory to have a CE marked HMI? Okay, all of the components that go together to make up a control system have to come together, and if that control system is being designed and built, it will be designed and built to a standard called IECEN 60204 Part 1. It's basically the IDEC's guide to making a machine safe from an electrical control perspective. If any component in there isn't CE marked, then it is unlikely that you can presume compliance. Remembering that if you remember before, I said that the standards are your means of presumption to conformity. So if you're trying to build a machine and saying it's compliant to 60204 Part 1, then all of the products that make it up have to be compliant. There's one option which is a little bit more complicated, is where you take multiple devices together and take it out to a third-party test house, but I'll cover that in another webinar. Do we have any other questions at all? Oh, this is quite a lot to scroll down, actually, isn't it? Here we go. Our machines are highly depending on software developers for safety. We are finding that verification of this standard is very, very hard. Okay, yeah. If it depends on the type of piece of equipment. This is from Gerard, sorry. If the equipment is covered under the machinery directive, then you have 2 or 3 standards that you have to get engaged with. If it's highly complicated equipment, you will probably have to work with 62061, which is the safety related control functions on machine for electrical, electronic and programmable equipment. And within that standard, it asks you to look at the integrity of the software and perform modeling on it. So you have to do V modeling and analysis of the software itself and test its functionality. Once it's installed, you have to then go in and do the fault injection, which I mentioned before. So it's extremely difficult. I'll be interested to know, Gerard, what type of equipment that you're looking at and what type of machinery it is. If you will ping me afterwards, I can have a chat with you about the standards that relate to that. So are there any other questions? No, I think we've got them all covered there. What I would offer is that you see my phone number, you see my email address there. I say I'm part of a team. We have guys across Europe. We have APEM sales guys across Europe. And so if you have any questions on machine integrity, machine safety, or just IDEC product or automation, please give me a call and or an email, and I'll be more than happy to do a one-to-one webinar with you. At these times, unfortunately, can't travel so much, but increasingly we're doing a lot of one-to-ones. And also, you know, with the iPhones these days, sorry, there are other phones available. With the phones these days, if you've got a client, walk around your machine, take the camera up to it. It's as good as my eyes. I can look at it for you there and then. The other thing we've been doing is working with people and their CAD systems and literally doing live edits on screen with that. We've done it with a couple of AGV manufacturers where we literally make changes there and then on the screen. Thank you very much for your time. I hope you enjoyed it and look forward to seeing you at the next webinar.